Okay, here we are. It is version 6 of our password manager app, and we have had quite a busy day yesterday. We got quite a lot done actually. We made a way that we could create an account. So we had this create account creation option implemented, and now we just got to test it and just kind of make sure it works, but that's later on down the line. And we also looked at encrypting the data. Did we get that? This was trouble with deleting things from this. I should come up with a better system. Maybe like stack all of our done to dos in a different list so that it's obvious what we have done. But we made some good progress yesterday. That's right. We were storing their password, and we were storing the password into a file. And now we have, if I go to the files, we have this here. This file here, and we can see that we did a practice one where we got the website, the username, and the password, which is fantastic. So this is all working nicely. This name of the file is linked to the user through the code. So our program can easily find this file, even though it'd be very difficult for a human to find it, which is great. And we've looked at hashing and that kind of thing in order to store our user data and to link that user data to this file here. So today what we're going to do is we've got this way to store things, right? And actually we should probably run through that just to kind of show this off again. I'm going to try and zoom out when I'm programming today and zoom in when I'm in the console, just so that it's a little bit easier for you to see the code when I'm writing it and see the output when I'm running it. But if I forget, I'm sorry. So we're going to log in as Bob with his super strong password. I will never not say that because it is the strongest password in the world. And we are going to store another password. So we'll pick number 3, and we're going to look at this. It's starting to look really good. We're starting to kind of really get the feel of an application here. So our website name, let's add in a website called Google. And our username might be, I don't know, my Google name. Could have done a better one. This is just for test data, right? I'm not actually. This isn't my actual stuff. Let's have let's have a really vulnerable password, like password. There we go. Look at that. It instantly wrote it in. I don't know if you saw that. I don't know if you blinked and missed it, but that is written in now. www.google.com, my Google name and password. So they are written in there. Now, what we want is when we type this stuff in, we want it to be saved in this file, but we don't want to be able to read it straight off the bat like this. We don't want to be able to see www.google.com, my Google name, password. What we actually want is just gibberish that no one can read. Okay, and that's what we're going to be implementing today. We're going to be implementing encryption. Now, hopefully I highlighted the right word. Now, let's increment the version first, because I quite often get carried away and forget that. So let's go to version. We're on 1.2, week 2, week 2, even though it's a 1, because we started at 0, obviously, because that's what we programmers do. And day 2, and for some reason I started the day counter at 1 rather than 0, just to make it extra confusing. So there we go, version 1.2. Doesn't really matter, has absolutely no basis on our application whatsoever, but it's a nice thing to increment. And if you've come up with a better versioning system, well, let's face it, if you've done anything different to what I've done, you've come up with a better versioning system, so pat yourself on the back. Okay, so we're going to jump into our storage.py file where we are storing the password, and we're going to write 2 functions in here. We're going to write an encrypt function where we get given a plain text string, and we then encrypt it, and we're going to return cipher text. Okay, so our ciphertext is going to be the text that has been encrypted, okay? And I will initialize ciphertext at the top here as an empty string. Okay, and then what we're going to need is we're going to need a decrypt function. So when we read the stuff out of that file, we are going to have to convert it back into plain text. So we're going to write a decrypt. And if you see me twinge at any point today, I've sat really poorly today. I've been an absolute sloucher, and I'm experiencing some mild back pain. So every now and then I'll hit an uncomfy spot, and my face will probably turn a pale color. And I apologize for that. I will try to sit better. So our decrypt function is going to take our ciphertext, that encrypted text, and it's going to have our plain text as an empty string, and we're going to return that plain text. Now, this isn't everything our functions are going to do, right? This isn't, we need to actually, in the middle here, we need to do a few steps. This isn't it. This is just the kind of skeleton of it. Now, what I'd like to do is I would like to write a little function that tests this, okay? So, because I don't want to go through logging in and adding in account details every time. So what we're going to do instead is we are going to write a little test encryption function here. Okay, so we're going to say def test encryption, and there is a kind of style of programming called test-driven programming, test-driven application, test-driven something, where you write your application from the point of view of testing it. So the whole, you don't like write your code and then test it. You like, what do I want to write? Okay, how will I write a test for that? Now I'll write the code and then I'll try and make it pass the test. And so you constantly like thinking about how you're going to test the code kind of before and during while you're programming it. And the testing is like a real part of the development process rather than it being a thing that you do at the end. And so we're going to try and embody some of the spirit of that. This is by no means a test-driven development 101 tutorial, but we're going to try and do a little bit of test-driven development. Okay, so we need, for store password, we need to give a UID. Now we know what the UID of our file is currently because we know it's just a file name. So if I come here, I'm going to take this file name, let's rename this, right click on it, rename, and then I can just copy, Control C, and that's our UID, okay? Now, obviously, in our actual program, we're going to ask the user, we're going to generate the UID, and then our program's going to forget about it. But while we are testing this, it will be helpful just to know what the UID is. So I'm going to say UID is equal to, and then pop it in a string. There we go. So that's our unique identifier. And this will help us target this as a file, right? So then we can call the store password function because actually we don't care about being logged in right now. We just want to make sure that this is encrypting and decrypting. So we're going to bypass all of that and we're just going to run the store password function right off the bat. So we're going to say store password and we're going to give it that unique identifier, the UID. Now this returns nothing, it just kind of does its thing actually. So what we're going to do is instead of all of this, we're going to comment all of this out, okay? And instead of saying, you know, get this input from the user, we're just going to set some standard test data in here, okay? So I'm going to put www.testsite.com. I'm going to put a username as let's say Bob123. And actually, I'm going to put a slash in here, testsite.com/testing. And let's also pop a password in. And let's try and just pick a fairly strong password that has some symbols. I'm just going to comment out this title as well, just because, so it doesn't show me an error line, because that would just drive me mad. And the whole reason we're doing this is so that we can bypass all the user input, press run, get the results, and then check to see whether they're working. And this should save time in the long run. Maybe we'll program this so well that we'll press run once and it just works, and then it will be a waste of time, but we'll see. Who knows? Won't be mad if that happens. I will not be mad. Okay, so let's do P for $, W0, R. Can I use another symbol? I could do a pipe and then a square bracket, a curly bracket. Yeah, password. Look at that. Okay, so we've got some numbers, we've got some symbols, we've got some letters. We could also do it. Oh, we have got a lowercase letter in there as well. So that's all fantastic. So we're kind of covering the different bases of what a password might be. We can see we're covering the different bases of what a website might be. We've got the dots, we've got the slashes. Obviously, there are other symbols that you might have in a web address, such as equals and % signs. So maybe we'll put those in there as well, just to check. And this is kind of good. This is fairly good test data. Okay. Obviously, if we were fanatic about testing this, we'd test it with a lot more data. But we're just going to start with a website name, a username, and a password, and we're going to try and just cover a reasonable amount of the bases. Okay, 10 minutes in, and we have Got absolutely nowhere. We've written some empty functions. Let's start getting into the meat of this. So we put in our test data here. So we should be able to just run the store password function now, and that should just work, right? But what we want to do is we want to encrypt these first, and then we want to write them, okay? So actually, what we're saying is, we're not saying website equals this string, we're saying website equals encrypt this. And we're saying website equals encrypt Bob123. And we're saying website equals encrypt passwords. Please do never use this password as your actual password. It's not good. Okay, lovely. So now whatever our encrypt function returns will be our information. Now it's just returning an empty string at the moment, so that's a bit useless. Now what I would like to do, let's go back to our favorite table from this series, the ASCII table. It's everyone's favorite table. Oh, God bless you, Wikipedia. Okay, here we go. So if we have a think about how we might encrypt something, yeah, we need to take a character. So let's say B for Bob. Where's B on this? So B here. Oh, hello. Oh no, I'm sorry. Okay. So we've got B on this line that is 98, right? And if we convert it to a number and then do something to that number and then convert it back to a letter, we've then encrypted it, right? We've changed what it is. And so that's kind of the premise we're going to be working on. Now, what I want to do is I want to find the range of symbols that we're going to work through. And so we're going to go from 33, which is the exclamation mark, and then all of these characters, these are all valid characters that we can encrypt to, and we're going to go all the way to 126. So 33 to 126, that's going to be our range. So let's pop that in. I'll leave the ASCII table here for now, just in case we need it. So I said 33 and 126. Okay, but that's our lower and upper bounds. In fact, what I'm going to do is I'm just going to say lower bound equals 33, and I'm going to say upper bound. Will that ever change? Probably not, but it's probably nice to have them in a variable. Okay, so now what we're going to do is we're going to say for each letter in our plain text, we are going to do an operation on that letter, right? So we're going to go through each letter, whether it's Bob123, so we start with B, then O, then B, then 1, then 2, then 3, or whether it's password, we start with P, then 4, then $, and so on. You get the idea. And then we're going to perform an operation on that letter. So we're going to say, let's say cipher, no, let's say ASCII letter equals ORD of letter. Now, ORD, if you remember, takes the returns us the number of that letter. So if I just jump into the shell very quickly, we can see that if I type in Python 3 to run Python, and then I type in ORD of A, I get 97. So we get a number when we use the ORD function. And that number, if we go back to the ASCII table, our favorite table, we can see 97 is in fact A. And so that is lovely. So we are getting the ASCII letter by using the ORD function. Let's just move this over. Let's get rid of our files. Let's give ourselves some space here. And let's zoom out a little bit. Okay, lovely. Okay, so we've got our ASCII letter. Now we're going to perform an operation on that. Actually, what I should probably do is, it's not our letter, it's our ASCII number. Okay, so we also want to just make sure that's an int. I'm assuming it does. Yeah, it does. It must come back as an int, actually, thinking about it. There's no need to do that. Okay, now we're going to perform some kind of mathematical operation on it. And what I'd quite like to do is I would like to be given, when we encrypt this, I'd like to also, as well as being given the plain text, I'd like to be given the UID. Okay, so we're going to link this to Bob. So in all of these things here, we're going to pop in a comma and a UID. So when we're calling these functions, we're going to give in that unique identifier. Okay, so this unique identifier is going to determine the shift that we do. So we are going to say shift is equal to, and then what I really want to do is I want to convert the number. So for instance, in our unique identifier here, it's D7, right? It starts with D7. So this is just a hexadecimal number. It's got some letters in it, but we can actually convert that to an actual proper number that you might understand if you don't understand hexadecimal. And we can do this by converting it. Now, I'm pretty sure if we take the first two letters, we can say UID from the start up to the second character. I'm pretty sure that's how it works, right? So if I had a string, let's say string equals hello, and then let's say string square brackets colon 2, will that get us he? Yeah, fantastic. So this will get us the first two letters here. And we then want to convert that. So we're going to say int and into base 16. And will that work? Will that work? Let's test it in the console here. So UID equals, and I think it's, what was it, D7? D7 3B. Let's type that in here. D7 3B. And then we're going to just copy this and paste it in there and see if it works. Ooh, I have to right click and paste it in. Amazing. Okay, fantastic. What if it was a lowercase d? Will that throw it off? D7 3B. And then we run that again. Okay, fantastic. So you can see the number D7 actually in hexadecimal is actually the number 215. Okay, so this means that we're going to add like quite a lot to it, right? But we'll come to that. So our shift equals in UID, first two numbers there, and they're completely random, right? They're going to be somewhere between 0 and 256, but we don't quite know where. Because we're going to take it from that unique identifier, and that unique identifier is linked to their username, okay? And you have to hash their username, and you have to hash that hash in order to get the UID, and then you have to do the shift. And so I feel like it's definitely not bulletproof. It's definitely not safe. It's definitely not something that you would use in industry. But for a little project that we're doing, I think it's more than enough right now. So this is our shift. This is how much we're going to add to that letter, okay? And so now what we need to do is we need to make sure that we don't go past 126, right? Our ASCII number is going to be somewhere between 33 and 126, and we need to make sure we don't go past that. And so what we're going to do is we are going to say for I in range shift, and we're going to go do this so many times, okay? And we are going to say ASCII number plus equals 1. So we're going to add 1 to our ASCII number each time, and then we're going to say if ASCII number is greater than 126, then our ASCII number is going to be equal to our lower, actually, yeah, I should have put upper bound here, not 126, is if our ASCII number is greater than our upper bound, then our ASCII number is equal to our lower bound. So we're going to wrap it back round. If it goes to 127, no, it's 33 now, not 127. And we're going to say elif our ASCII number is less than. Why would it ever be less than? Why would it be less than? There's no need for that. There is no need because it's not doing any taken away. That's silly. Yeah, that's really silly. So if it exceeds, there might be egg on my face there. We might get to a point where we should have implemented that, but no. So we keep adding to it. If it gets greater than 126, we're going to flip it back round to the start and then keep going up. So if we have this scenario where it's like 215 and our number was already at like 120, then we're going to go up 5, back to 33, back up to 126, back down, and then end up on some number within these bounds. And so this is going to be really helpful. We're going to keep adding and keep going around there. This will then spit out a brand new letter. Now, it could potentially, based on what this is, it could potentially be the same letter as it started, right? There's nothing to stop it being the same letter, and that's okay. I'm gonna allow that. There's nothing wrong with that. Okay. What I'd also like to do is I'd like to introduce a little bit of randomness up here. Actually, let's just test this is working, shall we? Let's test this is working. So we're going to test encryption. We are going to store our password with our UID, and that's all we need to do. Okay, fantastic. Yeah, let's just hang on. This encrypt needs to return our string, right? Oh, hang on. I'm getting ahead of myself. So we do all of that, and then we say our cipherletter. No, we don't. We say our ciphertext. I'm sorry, I've completely lost the plot there. I forgot what we were doing. Our ciphertext is going to add onto itself the character represented by whatever our ASCII number is, and our ASCII number will have been changed in this for loop here as we go through this amount that's linked to our UID. Okay, and it is going to produce a different number. I'm having so many thoughts at the moment. This is doesn't happen that often. Maybe we could go through one letter at a time and convert it to a number. Right. First things first. Let's put this into a different function. So this for loop here, we're going to start getting loops inside loops, and it's much nicer if we kind of hide this loop. So what we're going to do is we're going to take this loop and we're going to put it in its own function. So down here, or up here maybe, up here, we will pop it in and we will say def change what should we say? What are we doing? We're shifting the number, aren't we? So let's say, let's call it Ascii Shift. Ascii Shift. Okay, and in the Ascii Shift, we will store the upper and lower bounds. We'll paste, didn't want to do that. We will take this for loop here, and we will paste it in here. We'll also take the upper and lower bounds, take that in there. And what do we need to know in here? We need to know what the shift is. And we also need to know what our ASCII number is. So we're going to, actually, I guess we could probably just know our letter. Yeah, if we know our letter, and I guess we could just return the letter. That makes sense. That makes a lot of sense. Okay, so let's bring these back in line before it drives me absolutely mad. There we go, lovely. So we're going to say our ASCII number is this. I'm going to get the order of our letter. We've got our lower bound defined. We've got our upper bound defined. We're going to go through the range defined by shift, which will pass into this function. We're going to add all of this, and then we're going to return our cur of our ASCII number, right? So this will do all the heavy lifting for us. This will shift our letter through the alphabet. And so now we can say, for each letter in our plain text, and our shift is equal to, let's take lower. Let's do 0 and 2. You can tell when my brain's really having to work, can't you? So our ciphertext is now, instead of adding our ASCII number, we're actually going to add the Ascii Shift function, and we're going to pass it our letter and our shift. Okay, our letter's here in our loop as we go through each letter in our plain text, and our shift is worked out here. Now, what I'm thinking is that instead of having one shift, we go through their UID. But what I think might be even better is we work out what their shift is, and then we do another loop. We have this whole thing in a loop where we increment. We're gonna have a number, right? We're gonna have a counter equals 1. And what I'm trying to do here is I'm trying to make it so that when we convert our letter, let's say A, we're going to convert that to another letter or a symbol. Let's say we convert it to the exclamation mark. Now, using our system at the moment, every A that we convert is going to be an exclamation mark. And so it'll be really easy to tell by some frequency analysis and by looking at patterns in the text. It'll actually start to be easy to tell what characters are what. And so what we can do is introduce a little bit of randomness where our letters aren't always the same letters, right? And so we're going to have this counter. And what this counter is going to do is we are going to add our counter to our shift. And so every time we go round, we're going to add a little bit of randomness. And actually, let's start at 0. And then we're going to increment the counter. So let's just talk this through. So let's imagine that our plain text was the string AAAA, right? So the first time we shift this, and actually the shift stays the same every time. Let's take this out of here and put it in here. Okay, our shift stays the same the whole time. So we start with A and we work out what our shift is. Our shift is 215 for Bob, okay? And we shift to the 215th position by wrapping round and wrapping round again. And let's say it becomes, I don't know, the square bracket, okay? So then we add that square bracket to our ciphertext. So that's now our A. And then we do the same thing with the next A. So we add 215, it goes round, we get a square bracket, we add that to the next. And so A is always a square bracket. Whereas with this, when we add a counter, the next A, because we've increased our counter by 1, our shift is actually larger, okay, than it was before. And so now, even though we're encrypting the same letter, it's going to be a different position in the ASCII table. And we could do different things to our counter. We might add 10 to it, right? Or we might add 2, or we might add some kind of repeatable pattern. It can't be random because we have to decrypt it. Okay, and so we need to know the system that we're doing so that we can then go through and decrypt it easily. And so we're going to keep it kind of, I'm just going to leave it at 1, but we could kind of use bigger numbers because we know that in this function here, in our ASCII shift, this is going to wrap around. If it ever gets too big, it's just going to wrap back around. So this could be kind of thousands long, but then this would take ages to run. And so it probably wouldn't be that efficient. Okay. This feels like it's just going to work. So let's try it. So let's stop this. We need to actually run this file. So rather than running our main.py, we want to run storage.py. So let's go into our .repl.it file and let's change main to storage.py. And let's go down to storage here. And we need to actually run test encryption. Okay, run. Okay. Look at that. Fantastic. So we can see here that we have the website here, then we have a comma, and then we have the username there, and then we have the password. Okay, now the username was, what was it? Bob123, so it's 6 characters. So here we can see we've still got 6 characters, but they've all been changed. And you'll notice that Bob, B-O-B, so this B here has turned to a curly bracket, whereas this B has turned to an exclamation mark. And so our encryption is working, and it's going to be harder to crack. If someone doesn't know how we did this, obviously, if you've watched this video, this encryption's useless because you know exactly what it is and how it works. But if you didn't know how it was encrypting, then this would be just a little bit more secure. Okay, fantastic. Now, I do see a problem arising from our uses of commas, right? Because if there's a comma in here, then that's going to be an issue. And I don't have a good solution for that. Where is comma in the ASCII table? Where is it? Is it this? Is it 44? Looks like 44. Okay. So maybe to bypass that, we actually start our lower bound at 45 just for the time being. Or unless in our function, if it's ever on 44, we add 1 to it. That's really stupid, isn't it? Yeah, let's just start at 45. Let's for the time being, because I don't want to have to spend loads of time worrying too much about this. So we'll start a lower bound at 45. And you can see we've changed that one number there, and now our program will still just work, but we'll get a different output. So this is actually a really interesting test. Because we've changed our lower bound here, we can run this program without doing anything different, and we'll get a completely different encryption. Let's have a look. There we go. So you can see this is encrypted completely differently now because we've changed that lower bound. But now we know we're definitely not going to get any commas. That's interesting that this here, there are 2 backslashes in a row. What was this? Oh no, this was website, wasn't it? www. What was it? Test. Dot. So a T and a dot translated to 2 slashes. Interesting. Okay, it's a bit of a giveaway. We've got XYZ there for www, which is a little bit of a giveaway. So maybe we could do something a bit more interesting with the counter. And if you want to implement that, be my guest. But we're going to leave that as it is at the moment. I think that is strong enough for the purposes of this video. So let's get rid of this random string that I've typed here as well. There's no need for that. I can't believe the code actually ran with that in it. Okay, so this is good. So we've got our ciphertext working, and it's being saved in our file in its encrypted format. We're using our UID as a kind of key to decrypt it, and we need that UID in order to be able to decrypt our stuff as well. Okay, so we've got our store password here. We need to now start working on our retrieve password, right? Because we want to find a certain password. Now I'm going to bypass any kind of retrieval, and we're just going to test the decrypt function here. So we're going to say helper.read. Did I make a read? Yeah, read file. And our retrieve password needs to be told the UID, and we're going to read file UID plus webs. Nope, not plus website. What am I thinking about? Plus txt. So we'll concatenate those two together. So that's our retrieve passwords function at the moment. We are going to say data is equal to helper.readFile. And then we're going to say data, and I think our read file literally just returns it as a big string. Yeah, absolutely. Okay, cool. So then what we're going to do, in order to make our data, to be able to work with our data, we're going to say data equals data.split, and we're going to split it every time there's a new line. So we chop it into each line. Okay, so we're going to say data.split/n, because I want to separate each individual line in this file here. So each one of these, I want to be a different element in an array. So we'll have a list where each line here is just a string. Okay, lovely. So now what we're going to do is we need to decrypt, right? So we're going to say, first we need to find the actual website. Okay, yeah, so we can say for item in data, we are going to split our item. So we should probably say for record, maybe, for record in data, we'll say records is equal to record.split, and we're going to split this on the comma. And this is why I took the commas out of it, possibly encrypting to, because it's actually a really crucial thing to be able to split on, so that we can take this line that we've got here, let's say this one here, google.com, and we're going to find the comma, and then we're going to split this, and we're going to split this, and we're going to split this into an array. So we'll have a list with these 3 as individual things in them, rather as one big string. Okay. Now what we're going to do is we are going to say if, really, I guess we need the website, right? We want to find the search site. and we're going to set that to www.google.com. Okay, so that's going to be what we're searching for. So we're going to say if decrypt, actually let's decrypt it first. So let's say stored site equals decrypt, and we're going to decrypt our record at position 0. And we're going to give our decrypt function our UID because we need that in order to be able to apply the same shift so that we can then take that away this time from our thing. So we've got our Ascii shift here. Actually, now I'm thinking about it, we could probably make this. Ooh, could we make this go backwards as well in the same function? It might be too much. Might be too much. Yeah, let's just make a Ascii forward shift, and let's just replace that function down here, Ascii shift, with Ascii forward shift, and we'll copy this whole function, and we'll make an Ascii backward shift. Okay. I could definitely put some thought into this and make it one function, but sometimes it's nice to keep things separate and make them more readable. So we need a letter, we still need a shift. Our ASCII number is going to be the same, but now instead of if ASCII number is greater than upper bound, we're going to say if ASCII number is lower than lower bound, our ASCII number will be equal to our upper bound. So if we get to the bottom, we then return to the top, and we go back down, reversing the process. We're retracing our footsteps. Now what we're going to do is we're going to go from I am range. We're not going to start at 0 this time. We're going to start at shift. We're going to go all the way but not including. We're going to go all the way up to but not including -1. And we're going to go -1 every time. So we're going to start at whatever shift is. Maybe it's 5. And then next time on the loop, we're going to -1 from it. We're going to go to 4, and then to 3, and then to 2, and then to 1. So we've got a backwards loop here. We're starting at the top, and we're going all the way down to, but not including -1, so all the way down to 0. And that should do it. So ASCII number, we want to now minus equal 1 from it. We want to take 1 away, I think. So we've got our ASCII number, taking 1 away, round. Yeah, this should work. So let's test this works, and let's okay, so we've got our plain text here, we've got our counter. So we're going to copy all of this, and we're going to pop it in here. Okay, and we're just going to kind of reverse everything. So our shift is the same. We're going to keep that the same. Counter at 0. That's absolutely fine. Although we know our counter's not actually going to be at 0. Our counter's going to end up at whatever the length of our string is, whatever the length of our plain text is. So really, we want to say our counter is equal to len of our ciphertext. And we're going to take 1 away from it because we started at 0. I think that makes sense. Yeah, that makes sense. And then we're going to say counter minus equals 1. We're going to do an ASCII backward shift. And we're going to say shift add counter. That's fine. We're going to keep them the same. Is this going to go horribly wrong? Find out shortly. Okay. So we've kind of just copied stuff and tweaked some things, and so I'm expecting there to be maybe an issue with how with missing something, but we're just going to kind of pop in a test here, right? So let's do this. So retrieve password for record in data, record equals record dot split, stored site equals decrypt record 0, and then we're just going to print stored site. Now this will actually accidentally encrypt a few of them that are not encrypted currently, but the ones that are encrypted, it should decrypt them. So hopefully, let's pop our retrieve password function in here, pass in the UID, and let's see if this does anything. I'm nervous. Okay, interesting. Equals record 0 UID, and our decrypt function expects our ciphertext, then our UID. For each record in our data, our record equals record.split, and then we're passing in that first. Let's just print, actually, let's print record 0. Also, am I returning from our decrypt function? Turn plain text. Yeah. Ciphertext. Duh. Okay, yeah. I told you. Copied and pasted something. Something was bound to go wrong. So I'm saying plain text is an empty string, and then I'm just doing nothing with plain text. I'm going for the letter in plain text, and I'm returning plain text, but I'm only operating on ciphertext. But I don't want to add to my ciphertext. I want to add to my plain text. So we're going to copy that. We're going to paste that in here, and we're going to not go through our letter in our plain text. We want to go through our letter in our ciphertext. Okay, let's run that. Okay, it's definitely doing something, but it's not doing exactly what we want it to do. Now, let's run it again, just with a bit of a wider screen. Okay, that is how wide it needs to be. So we've got here our encrypted data, and then here we've got our decrypted data. And as you can see, if I zoom in a little bit, it's not really decrypted, is it? We've encrypted it too good, and I have definitely made a rookie error here. So let's just try and see if we can problem solve this. So we are encrypting this. We have our ciphertext, we've got our counter, and we are adding 1. So our shift, when we decrypt, starts really high where it would have ended. And then we're just applying that backward shift. Let's just experiment, and let's just say, what was I concerned about here? I was concerned that my counter maybe didn't need to be -1. Length of our ciphertext. I'm gonna each letter. Let's print counter as we go through this. Is that a good idea? Okay, rather than doing this, what we're going to do is we're going to say stored site equals decrypt record. What record are we looking for? So we're looking for the 0, 1, 2, 3, the third thing in the array. So let's say let's get rid of this for loop for the time being, because all we really want to do is just check that our decrypt function is working. I knew this would take a little bit of time, so I didn't want to overdo it. So we are going to say that record equals data at position 3. Are we? What are we saying? Data at position 3 dot split. Okay, and then that is going to just take our one thing. So we're not looping through all of them. So now if I run this, okay, now we can see this working. So now we can just do some really quick tests just to see what would happen if we change some things. So first of all, what if I did -2 here? Okay, that's just more gobbledygook. What if I did -0? Or don't minus anything? Okay, so we don't think it's that. So I think -1 is fine there. So our shift is always the same. We're just chopping the UID there. Our UID is the same. That's all fine. So our plain text is plus equal our backward shift from our letter, for letter in our ciphertext. Oh no. Okay, I'm a dingus. We don't need to start our counter at the end. We need to start it at the start because we're starting. Yeah. In my head, I've been going backwards through the ciphertext, but that makes no sense. Right. Oh, hello, and welcome back to Overcomplicating Things with Mr. Johnson. Okay, so we can keep this the same. We got our plain text as an empty string, just like in our encrypt, we've got our ciphertext as an empty string. A counter set to 0, a counter set to 0 here, and we're going to just add 1 to our counter down here. I don't know why I've typed print here. Let's just get rid of that. And we're going to add our shift to our counter. Okay, will that have fixed it? Not quite, but kind of. You can see we've got RRR. So this has basically worked. It's just wrong, which is good. So this is really good because this should be www, right? So we know we're only out by like RSTUVW. We're out by 5. Now, why are we out by 5? That is a great question. So when we're decrypting, all of this is fine. What are we doing up here? ASCII backwards. We're going from our lower bound. So we're going from shift. Now the from, yeah, so our shift. Ooh. Okay. We're using shift here. When in our forwards one, we're going up to, but not including shift. So we need to go from shift -1, -1. Let's run that. Okay, we're closer. We're so much closer. Okay. ASCII number minus equals 1. If our ASCII number is less than the lower bound, our ASCII number equals the upper bound. Yeah, that's fine. Okay. We're going down to 0, taking away 1 each time. We're taking 1 off of our ASCII number. We keep going around there. I can't believe this isn't working. I mean, it has worked. It's just not worked very well. SSS. So I think we're like 4 at RSTUVW. Why are we 4 out? What have we done? What have I done wrong? Oh, this is so annoying. It's interesting that we've started with that www. If I hadn't started with those 3 letters, I wouldn't have realized just how close we are to the solution. So let's just compare this forwards and backwards and see what we're doing differently. So we are going backwards now through the ASCII range, and then if it gets less than the lower bound, then we're popping back up and we're going back down. It's equal to the upper bound, and then we go back down, and then we're just going to keep doing that until we get to wherever we get to. So that's all fine. That's all fine. Why wouldn't this work? Okay, so our counter starts at 0. Our counter in Decrypt starts at 0 as well. We've got this, we've got that for letter in ciphertext, for letter in plain text. Our plain text is as our letter, our shift plus our counter. Oh, this is annoying. This is very annoying. What if I said our counter equals 1? What would that do? That's back to RST. Okay. So what if I said our counter was -3? Would that fix it? BVW. What if I said it was -4? Does that? Oh no. Okay. Something's gone horribly wrong. Have I changed how we encrypt? You can see here we've got. Actually, let me zoom in a little bit. You can see that we've got www L TKST. So that should be test, but that K is wrong. Site.com. This should be a slash testing, and then we've got a curly bracket. Oh no, it's all so close and yet so far. And there's going to be something very, very stupid, and it's just a case of trying to find it. That's all it is. That's all it is. I'm going to have a minute of just silent looking. I know it makes for compelling viewing. While I try not to talk out loud so that I can focus on this and see if I can find it. I think I've solved it. I think I've solved it. Yep. I was I was trying to decrypt the wrong one. Oh, that's egg on my face. Okay, it does work. I was just choosing the wrong record to split. I was trying to decrypt this line here, number 4, when I needed to be trying to decrypt number 5. Simple as that. Why wasn't number 4 working? Because we encrypted that slightly differently without the counter. I believe, or something's changed since then. So actually, I'm gonna delete all of this. Let's get rid of all of this, and let's just try this again. Okay, so what's going to happen now is we are going to get this to encrypt. We're going to store our passwords, okay, and the password that we're going to store is here. So we testsite.com/testing equals %. Interestingly, it says equals W here. Sure, that's fine. I'm sure that's just fine. Now down here, I've not balked anything up, have I? I've not made any silly adjustments. Let's give ourselves a bit more screen space. So this is all fine. I knew it was great. I knew it was wonderful. I just doubted myself for a second there, you know. Yeah, I was just looking at the wrong data. We've all been there. We've all been caught just looking at the wrong thing. But here we are, and we have this now. So this should go through and look at the third thing. So actually, no, we can just put our for loop back in now, right? So we can say record equals record.split again, and let's put in our for loop. So we're going to say for record in data, and say record equals record.split. We're going to say stored site equals decrypt. We're going to print that, and we're going to print that. And so what we'll do is we'll say print record 0 will be the encrypted. Now, the kind of test-driven side of this, maybe not the most exciting thing, but it is a really necessary step and something that you should try and get into when you're developing, is that you're not just trying to write an application that works, you're trying to write an application that works in like any scenario, right? And so you're trying to test it as much as possible. So if we run this, okay, so we can see these are not encrypted. So where it says encrypted here, site name is not encrypted, so it's not coming back in a decrypted format. Same with wikipedia.org. That's not, and the same with Google. But here we have our encrypted thing here, and we are getting it back decrypted. There is an issue with percent signs that I'm not sure why it's a W. but I'll look into that kind of between now and then. And we also have just a blank line that has not done anything. And so this is great. We now have a way of encrypting something and decrypting it. Okay. And so let's change up our test data. So let's change this to MySpace, everyone's favorite website, /social equals profile exclamation mark percent sign. And let's put a percent sign in here as well, see if that's just a bug or if that actually works. We're going to have cool guy 81, obviously. And our password is going to be beans52. Okay, so we will now store that password, and then we will run through this again and see the encryption decryption in thing here. So we can see that, yeah, every percent sign is it's coming back as a W. But we can see that the general gist of it is working. myspace.com/social. I will have to look into why we're getting W's. Is that at an extreme of the ASCII table? Oh, it's 37. How did it get there? Ooh. Ooh. Changed both lower bounds. And so when it was encrypted, that shouldn't have been how is it? How? Because a percent sign isn't accepted. Right, okay. So we have to use this, don't we? We have to. So actually what I'm going to do is I'm going to change our lower bound to 33 back to how it should be. Where are we? Help. So our lower bound should be 33. Okay, trying to cut the comments out was silly because actually it's led to a bug in our program where if a user uses something on the ASCII table like an exclamation mark, which they're very likely to, or a percent sign, or a dollar sign, or a hash sign, okay, it's not gonna come back here because we're cutting it off at 45, and that's no good. So what we're going to do instead is, and that means if someone puts a space in their thing as well, that could be a problem if they have a space. Do people have spaces in their passwords? Oh, we should probably do 32. I was going to use a space. This has become more problematic than I was anticipating. Oh dear. Okay, let's not worry about spaces for now. But let's remember that that's a bug. Let's just write a comment here and say there is a space bug. Make sure you deal with this. Okay, that's fine. Now we've logged it. It's all fine. And let's just pop this in here for good measure as well down here, just so that I really remember that there is a big old bug there. So we're going to put that down there. And when we make our file, so when we put all of these together, we're going to add our delimiter. Do you remember here? Oh no, we didn't. We didn't add that in. I dreamt that we added that in. Let's go back to our helper file. And we've got our right file here. And can you see we're adding in a comma? Now, what we can do instead is we can add in a delimiter option. So delimiter, a delimiter is the thing that goes between everything, right? So we're using commas as a delimiter to go between them. And we're going to set that equal to a comma by default so that it doesn't break anything that already exists. But we're going to add in our delimiter, again, lack of screen space here, I do apologize. We're going to add in our delimiter here. Okay, delimiter. Have I? Delimiter. Okay, delimiter. And it's by default, it's going to be, hello, it's going to be a comma, but we're going to set it as a space in this one. And so if we go back to our storage file, and here, helper.write file, for storing our passwords, we are going to say delimiter is equal to a space character. And so we're going to separate our data out by space. Now, we need to come in here and just edit these records. I'm just going to replace all of these commas with spaces. And I could have done this in 15 different ways that would all have been much quicker than this, but there's nothing like doing things the hard way. Okay, so we've got our different Okay, we've replaced all the commas with spaces in here now. Okay, and that's how we're going to be chopping it up. And then if we go back to our storage file, we're in our store passwords, retrieve password. In our retrieve password, rather than splitting it by a comma now, we're going to split it by a space. Okay, so now if I run this, and let's change this up again because we're going to add we're going to add one more to this. So let's go for bing.co.uk/search equals Google, because that's why people use Bing apparently. My username, because I've got to be logged into Bing to use it. Obviously, my username is Grandad101, and my password is I've lost all imagination. Oh no, my password is just going to be password. Okay, so let's run this and let's have a look at our results. Okay, so we have encrypted here, decrypted. Oh no. What have I done? Bing worked, nothing else worked. Nothing else was happy. But, oh, okay, yeah, because we've changed our encryption decryption between 33 and 45, it's thrown everything else out. So all our old data is done. I'm glad this is test data and not actual people's data, because we would have just lost everyone's passwords. That would be bad. So we're just going to delete all of these, okay? And we are going to run this again. Okay, and now we can see here that we've got this stored here as an encrypted, and then when we decrypt it, we get the full thing. And as long as no one puts a space in anything, our program is A-okay. Okay, fantastic. So now we should be able to run our actual application, right? Just to finish this off and end the pain and misery that you have suffered while I've walked my way through this. Let's go up into our .repl.it file and let's change this to run main.py instead of storage. And we are going to go into main.py, and I don't know why, we don't really need to go into it, but let's just run this. Okay, we're going to log in. We're going to be Bob. Our password is password1. Almost forgot then. It was so secure. It's difficult to remember. Okay, and what I'm going to do is I'm going to rip out all of these. Okay, so I'm going to start afresh for Bob. And I can do that while we're in the program, so that's absolutely fine. And we are going to store a password. And we are going to store a password. Oh no, I've ripped out all of the functionality in store password, haven't I? Okay, I might have just saved bing.co.uk a few times. Yep, there we go. Not that I can read that, but that's bing.co.uk. So let's take that out and let's go into storage. And you can see here that I put in. Go away. You can see here that we commented out these lines. Yeah, and we replaced it with this. Now what I need to do is I need to cut this here, and I need to replace this string. So I'm going to take this whole string here, and I'm going to replace it with that line. So we're going to say helper.getTitledInput. We're going to give it the title. We're going to give it the website name. That's the title. I'm going to give it the UID, and that will return to us the user input. Let's just tell it what the title is. Get rid of that comment there, and then we're going to do the same here. So we can take our titled input for our username, and we'll replace Grandad101 with this. And we're going to take our, oh dear, what am I doing? Okay, I need this bracket. I need to get rid of that. I've balked up somewhere here. This needs to go there. I missed a bracket. Okay, so bracket, comma, UID, bracket. Okay, so we'll take this last one, this password one, and we'll cut that, get rid of the comment there, and we'll replace passwords with that. Okay, fantastic. So their input is immediately being encrypted, and then we are storing it in the text file. Right. Let's give this a whirl. I promise your suffering will end shortly. Okay, so did I press run? Oh, I have now. So login will be Bob. Was it just Bob? Yeah. And we'll say password 1. Okay, and we're going to store a password. Add account to password manager. Website name. Let's add in www.google.com. Our username for that will be Mr. Johnson, and our password will be hello, goodbye. Another terrible password. Voila. Again, could have had a nice screen there that was like password stored successfully, but oh well, we haven't done that yet. And we can see here that we have this password stored. We've got my username, Mr. Johnson. No, no, we don't. We've got the website, www.google.com. We've got my username, Mr. Johnson, and then we have my password, which was hello, goodbye, all stored there in this text file and encrypted so that if anyone came along to it, it would be difficult for them to understand what it was. There's an interesting recurring plus pattern here going on. Okay, I've come to the end of my sanity and the end of the video. We have been able to encrypt our data today, which has been fantastic. And tomorrow we'll look at how we can retrieve passwords that we saved in here. So for passwords that have been stored, we can then type in a website that we want to find, and it will give us our username and our password so that we can then go in and sign into something, and thus kind of create this whole application's whole purpose. Thank you so much for watching today, and hopefully I will see you in the next version 1.3, where we will pretty much round out the functionality of this. So yeah, I look forward to seeing you then. Thank you for watching. Take care.